Hi everyone, am I visible to you and am I audible to you? Can you drop me a message, please? Can you hear me, guys? Can you just drop a message if you can hear me and you can see me on the video? Hi Ramakrishna. Hello Mrityunjay. Okay. So thanks Ramakrishna, Mrityunjay and more people who have joined. Can you please press the like button and just drop a message so that I know that you are able to hear me? I mean, two people have confirmed, but just to be double sure, can you just press the video like button once and just drop a message? I'll just wait for maybe half a minute to 1 minute. And then we can start, okay? So the agenda is very simple, Mahesh. The agenda is we are going to have a live quiz. But as I told last time, the format of the quiz this time is going to be slightly different. And what I want here to happen is previously we used to have a lot of live quizzes, and in those live quizzes I used to prepare a set of questions and then people used to join. Here, what I'm wanting to do is I do not want to people to play the games in silos. So what happens is 10 people join the meeting, all 10 are playing in silos. So that's not what I intend to do now. What I intend to do is it should be more engaging and it should be more interactive. So for example, if I bring a question on the screen, right? Then uh, many people can answer through comments. Many people can give right answers, wrong answers, and then we discuss why something is right and why something is wrong. So what I'm trying to achieve is two things. One is more of an engaging session, and second, somebody who joins after 5 minutes, 10 minutes, or let's say 30 minutes also, they will not feel like I have missed the live quiz. They can join anytime. Okay. So how this quiz is different is here you no need to play live on some other app, or you no need to focus on answering fast or nothing like that. Okay. What you need to focus on is when the question comes on screen, what is your conceptual understanding of that? What should be the right answer? If somebody says, no, not option A, it should be option B. Why somebody is saying option B? Things like that we can discuss. With that in mind, uh, I request you to keep it very engaging and very uh, interactive. The purpose is very simple. We are here to learn from each other. Okay. Let me go ahead and try to share my screen, and I will just show you the first question of today and then we will discuss. So the concept is very simple, guys. What is going to happen is one question is going to come like this. What you have to do is you have to simply comment in YouTube itself. No need to go anywhere else. Just comment in YouTube itself. What do you think is the right answer and why? Okay. So the first question in front of you, in a neural network, which activation function can lead to vanishing gradient problem? Relu, sigmoid, leaky Relu, or softmax? What do you think and why? Okay, so I can see answers coming in here. Mahesh says Relus. I'll just read your name, whatever you have written here. Krishna says sigmoid. Vish says sigmoid. But that is what we want, right? We want different answers coming from different people, and then we discuss that. Meanwhile, there are 13 people live. If you can just press the like button once, what will happen is recommendation will go to other people and they can also join. Okay, so just press the like button once, guys. Mrityunjay also says sigmoid. So I'm getting 5 answers here. Out of them, 4 are saying sigmoid and 1 person is saying Relu. So my question to Mahesh is, why do you say a different answer? And Satendra also is supporting Mahesh now. Why do you think Relu will give a vanishing gradient problem? And I'm getting a softmax answer as well. So how we should do this is basically, what do you think is the most appropriate answer? Okay, I know that there could be little bit of confusion between two options. In that case, you have to choose what is the most appropriate answer in this case. So in this case, since sigmoid squeezes your output between 0 to 1, right? So there is a huge possibility of falling into the vanishing gradient problem. So all these questions will be very conceptual in nature. All these questions will be of different flavor and different difficulty level. So in my view here, the answer, I'll just wait for if someone else wants to answer. Yeah, so many people are saying sigmoid, which is the right answer in this case. And ReLU brings a different kind of problem, but not this problem, vanishing gradient problem. Okay, so if I go to the next slide, I have also added a simple explanation here for all the answers. So here you will see that sigmoid activation can squeeze input values to very small output between 0 to 1, leading to vanishing gradient. So that is one of the known problem of sigmoid. Okay, it will squeeze your value between 0 to 1 and it can lead to the vanishing gradients. What I want you to do is I want you to comment even if you feel that answer is not right, because that way only we will discard the wrong answers. Okay, let's go to the next one. There is no timer, nothing. You can take your time and answer. You can debate. You can give right or wrong answer. Doesn't matter. What does back propagation calculate in deep learning? What does back propagation calculate according to you? I have knowingly put questions so that some questions may be slightly confusing, and then we will try to answer those. Weights. Back propagation calculate weights. Are you sure? I am saying, what does back propagation calculates? So there are some confusion. There are some different answers between weights and gradients. Please take some time and try to understand what is the question here. When back propagation happens, what is the thing that is getting calculated? I am not asking what is the thing that is getting updated. I am asking what is the thing that is getting calculated when the back propagation happens. So you are confused between weights and gradients. Hence, I'm saying, think one more time. I'm not asking what is getting updated. I'm asking what is getting calculated. These kind of MCQs, they will put you in nowadays some filtering first round of your interview. Okay. And then you will get confused. So people who have joined now, it's a very different new kind of quiz setup that we are playing today. There is no timer, nothing. It's more on discussion based. So what do you think should be the answer here? So I have knowingly put some confusing options. Reason being, the intent here is to discuss concepts. Okay, that is the only intent. So when you're to keep it very simple, when your back propagation happens, right? The only thing that is getting calculated is gradient with respect to the weight to update them. So the end goal is to update the weight. Okay, but my question here is what is getting calculated when it moves down, when it moves back, right? So in this case, the gradients. Remember, some of the questions will be very, very simple and some of the questions will be tricky. Some of the questions will be complicated as well because I have to keep in mind all the level of students. Fine. So there is a very nice question here. What is gradient? So I want one of you to answer. I can answer this, but I want one of you to answer. What is gradient? Somebody is asking. So gradient is basically if x squared is my function, then 2x is the value of gradient. Gradient is your derivative with respect to what you want to update. Okay, for example, if my fx is equal to x square, gradient with respect to x is basically derivative. So that helps you in telling how to optimize that function. Okay, so gradient is a calculus concept basically. Let's go to the third one. Which optimizer is known for adaptive learning rate for each parameter? Which optimizer will use adaptive learning for each parameter? Remember, each parameter is important here. Which optimizer will do that? There also you will confuse between option C and option D. Okay, I'm sure that you will discard option A and option B, but in between option C and option D, you will confuse. AdaGrad, the name says adaptive gradient. Okay, and Adam is basically an advancement on top of AdaGrad and RMS Prop, both kind of mixed together. Okay, and when we talk of adaptive learning for each parameter, right? In this scenario, I will go for Adam because Adam uses both momentum and adaptive learning for faster conversion. This is one kind of explanation, but also here we are talking about in between Adam and AdaGrad. If I have to choose one, right, which one I'll go for? So in this scenario, I'll go for Adam. AdaGrad also I had put for as one of the option, but I'm asking about for different parameters. Okay, both C and D in one way is acceptable answer in this scenario. I'll not say somebody who is saying C is wrongly saying, but out of these two, if I have to choose, I'll go for D. Let's go to the next one. Which of the following regularization technique adds a penalty proportional to the absolute value of weight? If you know the concept of various regularization techniques, then it should be easy for you. What should be the right answer here? I'm getting answers like L1. Any other answers like L2 or batch normalization? Everybody, if you are liking the quiz, can you please press the like button once? And in the comment, you can say you are liking so that I can continue on the same rhythm. L1 regularization. Okay. So many people are saying L1 regularization here. L1 regularization is the right answer. It's a straightforward conceptual thing. Okay. So which regularization adds a penalty proportional to the L1 regularization add a penalty based on the absolute value of weights, encouraging sparsity. So some people are saying L2, but this is L1. L1 is the right answer here. Okay. Let's go to the next one. Which of the following techniques can prevent overfitting in a neural network? As I told you, I have included answers from different flavors. Some of these could be easy, some of these could be medium difficulty, some of these should be high difficulty. Okay. So what do you think answer for this? Batch normalization or gradient clipping or ReLU or dropout? Okay. Some people are saying dropout, 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 dropout. Anybody says anything apart from option B here? Do you think anything apart from option B is making sense? Batch normalization is a different concept. Gradient clipping is a nothing to do with the overfitting, and ReLU is an activation function. So it's a straightforward question here. Dropout should be the right answer. Okay. So dropout randomly drops neurons during training, reducing overfitting. Let's go to the next one. What is the purpose of ReLU activation function in deep learning? What is the primary for purpose for ReLU? Do you think out of these four options? There are many things ReLU can do, but out of these four, somebody saying option B, that is introducing non-linearity. Somebody saying option C, to prevent exploding gradient. Somebody saying B and C, people are basically saying. Okay. So in this scenario, the purpose of ReLU activation function in deep learning is basically option B, that is to introduce non-linearity. ReLU helps you to prevent vanishing gradient, not the exploding gradient. Okay. So if I write here vanishing gradient, that will still make sense, but exploding gradient problem is not something that ReLU is interested in. So introducing non-linearity. Okay. ReLU introduces nonlinearity by seeing val negative values to zero, enabling the network to model complex functions. What does the learning rate control in gradient descent? What is the answer of this? And also when you are answering, you can simply say some reference to that. For example, you might be saying B and C about previous question, but if you simply say in this case, for example, the depth of the network, then I will know that you are answering this one only. Sometimes comment comes little late, right? What does learning rate control in gradient descent? Some people are saying, I'm guessing you are answering the speed of convergence. Is that what you are answering, the speed of convergence? And is anybody here who says the batch size or number of neurons or depth of network? Anybody here says any of these options? One person says option B, the batch size. No, that's not right. Learning rate has nothing to do with option B. Yes, if you change learning rate, then your convergence rate will change. So correct answer is convergence. The learning rate controls how fast or slow the algorithm converges towards the optimal solution. Fine. Let's go to next one. Which of the following deep learning models best suited for sequential data like time series? So what do you think? Is it CNN or feed forward or RNN or autoencoders? Okay, some people are saying RNN. Let's see some more answers in this. RNN, I'm getting I'm getting a RNN from everybody, which is basically this is a easy question. So whenever you have a sequential data, you need to remember the context, you need to remember what happened before, and whether it is time series or whether it is text kind of scenario, whether it is any kind of thing where memory is needed, right? You will go for RNN. RNN is an option which helps you whenever you need a memory. So RNN is the first concept in the world of deep learning where memory came into the picture. Okay, so whoever saying RNN is fine. RNN are designed to process sequential data such as time series or natural language, as I told. What does dropout in a neural network do during training? Do you know? Will it add noise to the input? Will it randomly remove neurons? Will it decrease batch size or will it reduce learning rate? What is that dropout will do? Many people are saying option B here. So option B is this is a easy question basically. So this is just a memory thing. Dropout does nothing but it randomly removes neuron from your training and it helps you to control overfitting. Okay, so simple. In a CNN, what do convolution layers extract from the input data? Do you know? When you are saying A, B, C, just say B hyphen features. For example, if you want to say features, simply say B hyphen features. That way I will know which question actually you are answering. So in a CNN, what do convolution layer extract from the input feature? Label, feature, weight, prediction. So many people are saying option B, features, which is right in this case. Convolution layer extract features like edges, textures, and shapes from the input data. So when you add a convolution layer in your CNN network, right, the job of that layer is to extract these features, which will be later used for the learning purpose. Which of the following do you think is a key challenge in training a deep neural network? High variance, vanishing gradient, overfitting, or all of the above? Which one do you think is the key challenge? People who have joined now, you can simply start playing and start answering because I have designed this in such a way that anytime you can join, you will not feel like left alone. So you can start from this question itself. Okay. So we have 20 questions. We are in 11th now. There will be 9 more. So which of the following is a key challenge in training deep learning? So high variance, yes, it happens because sometimes model produce high variance. Vanishing gradient, a common problem in the world of deep learning. Overfitting, a common problem in the world of deep learning. So in this case, all of the above. Okay. And here I'm asking you one more question, which look at the answers very carefully and then look at the options very carefully and then answer. What is the role of loss function in deep learning? calculate accuracy, calculate error, update weights, reduce computation. What do you think? I'm asking role of loss function or cost function, whatever you can say. Both are more or less same. To update weight, people are saying, but I disagree with this. To calculate accuracy, no. Satendra Kumar, no. That's not what loss function does. To update weights. Okay, let's discuss all these one by one. To calculate accuracy, it is not the job of the loss function. First of all, let's try to understand what is loss function or cost function. Loss function or cost function is a function that tells you what is the error in your model. Simply the error, measurement of the error in your model. Okay, so option B is right answer here. Option C, to calculate accuracy, is not right. Option C is not right. Please pay attention here. Option C is basically to update weights. Updating weight is not the job of the loss function. Updating weight is the job of the optimizer. I will repeat one more time. Updating weight is not the job of the loss function. Updating weight is the job of the optimizer using the loss function. Hence, loss function does not update weight. Loss function calculates the error, tells to the optimizer this is the error, and reduce computation is not applicable here. Okay, so loss function calculates the error between actual and predicted, guiding the model's learning process or guiding the optimizer on what to do, guiding the process on where to move, where the weights to move. That is what the job of the loss function. Okay, as I told you, some of the answers will be slightly confusing knowingly to test your concepts. What is the role of batch normalization in deep neural network? To regularize, to normalize, to speed up training, to prevent gradient vanishing. What is the role of batch normalization in deep learning? To regularize, to normalize, to speed up training, to prevent gradient vanishing. So basically, when you do batch normalization, right, it will normalize your intermediate layer and it will speed up your training. Here I'm talking about what is the role, what it does basically. Okay, not asking what is it, what it does. Okay, so what it does is it speeds up the training. So what is the job of this? What it does, it speeds up the training. That is the role of this. Okay, so pay the attention to, if you go to certification exams, right, for example GCP certifications or AWS certifications, right, they will play on these words only. What is the role? Role is that we are asking. So speed up training is the role. That is what it does to the model. Which of the following problem does gradient clipping help to solve in deep learning? When you do gradient clipping, then what happens? Overfitting, vanishing gradient, exploding gradient, data imbalance. Exploding gradient, Mrityunjay is saying. Well, how about other people? Some people are saying option D, that is data imbalance. Data imbalance has nothing to do with gradient clipping actually. Gradient clipping is basically limiting your gradient to one level so that it does not overshoot some limits. Okay. And in this case, exploding gradient is the right answer. Why? Gradient clipping helps prevent exploding gradient by setting a maximum threshold for the gradient. So it will not allow your gradient to go beyond that threshold. And due to that, what will happen is the explosion problem will not be there. Okay. What is the purpose of using early stopping in deep learning? To improve accuracy, avoid overfitting, reduce computation time, increase learning rate. Which number question you are answering? If you can just say, for example, if you are answering 15, you can say 15D, like that. What is the purpose of using early stopping in deep learning? Some people are saying avoid overfitting. Does anybody has any other answers on this? Okay, it's a easy one basically. You will do early stopping because you want to avoid overfitting. There is no rocket science here. Early stopping is used to stop training when the model performance on the validation set starts to degrade, avoiding overfitting. Okay. Which of the following is a major advantage of using transfer learning in deep learning? Which of the following will it require less data? Will it increase computation? Will it require more neuron or reduce accuracy? Here we are talking about transfer learning. Okay, so whenever we talk of transfer learning, it's basically model has learned the things from other data and we are utilizing that learning and kind of trying to tune that with our data. So it will always be requiring less amount of data. Okay, so transfer learning allows a model pre-trained on large dataset to fine tune on a smaller dataset, reducing the need of large data. In deep learning, what does the term epoch refer to? This is one question which many people have confusion on. Okay, hence I have put this here. Many people do not understand what is epoch actually. What do you think is a one epoch? One cycle of full training data, one gradient update, one batch of data, or one hidden layer. Okay, people are saying 17A, which means, does everybody agree with the meaning of epoch here? Ramakrishna ELI is saying C, one batch of data, which is wrong. It will not be one batch of data. One batch of data could be one single training also. I mean, one single training example also. Do not confuse one batch with one cycle of full training data. Okay. Once, let's say in your data set, there are 100 rows. One complete scan of all 100 rows. However you do it sending one observation in stochastic gradient descent. You do it sending 5 batches of 2020 each. But one complete scan of whole data is one epoch. Remember this always. Okay. And batch is like one shot how much data you are sending. 1, 20, 30, 100. That is a different concept. So when your model scans your data once completely, that is one epoch. An epoch refers to one complete pass of the entire training data through the network. Okay, don't forget this. Sometimes it is confusing. What is the purpose of weight initialization in deep neural network? To reduce training time, to prevent symmetry, to reduce overfitting, to improve regularization. 18 Kritarth is saying A, which is not the main reason why you do weight initialization. Weight initialization is done for a different purpose. So I'm not sure if you are aware of weight initialization technique such as GLODUT, etc. But what will think like what will happen if you don't initialize the weight? What I do not want my model to do is I do not want my model to have the same starting point for all the weights. Okay. So I want to have some kind of variance. I want to have some kind of non-symmetry. And when I do a weight initialization using different weight initialization techniques, right? What I do is I prevent symmetry of weight. So imagine a weight metric, okay? Imagine that all the numbers are same. That is option one. And option two is in the beginning, I have a choice of putting a normally distributed data in all these weights. Or I have a choice of putting different numbers in all these boxes. What will happen is that will allow my models to be more uh, flavorful, you can say, or it can have different flavors of weight. So when I'm initializing weight, what I'm doing is I'm preventing the symmetry of the weights. I do not want all the weights to be symmetric or near about same. That I do not want. So proper weight initialization breaks symmetry, allowing different neurons to learn different features during training. That is the reason for why you do weight initialization using weight initialization techniques. Okay. So if you are liking the questions here, guys, you can tell me in comment that these questions are good. You want to attend more sessions like this, and then I will come up with more questions. There are two more. We will go through that. But if you pay attention here, I'm putting conceptual questions of different difficulty levels so that all of you feel involved and all of you feel engaged. Okay. Otherwise, if I put everything too easy, some people will not find interesting. I put everything difficult, some people will not find interesting. Okay. So I can take your question, no problem. Yeah. And if you are noticing, all the quizzes are theme based. So today it's deep learning. If you go to Unfold Data Science live, you will see there are 4, 5, 6 different themes on which we had the quiz. For example, one of the last quiz was on RAG and LLM. One of the quiz was on ensemble learning. One of the quiz was on some other topic, some other topic. So today's theme is deep learning. Next time we can have a different theme. Okay. So the reason I don't go, I can go to advanced level, but again, you have to think about people who are new to the data science. Okay. So they should not be left behind, right? Out of let's say 20 people are there in the chat now. Some people may be very new, right? And if I bring all the advanced concept, it may be difficult for them. Okay, let's go to the next one. Which type of neural network is commonly used for image recognition task? Again, a simple one for newcomers. It should be easy for you. Yes, some people are saying they are new to the world of data science. So It's injustice to them to put all the difficult questions. Okay. So Birati Bhan, what do you think is the answer of this? These kind of questions are for newcomers only. CNN, yes, convolution neural network. Whenever we are talking of images, we are talking of convolution layer, we are talking of features, edges, all these things, and then CNN comes into picture. With that, let's go to the last one. CNNs are specifically designed to process image data, making them suitable for tasks like image recognition. Everybody knows that, no big deal. This one is a RAG-based question, which I have asked you previously in the community section as well in Unfold Data Science. Which of the following is the primary challenge while integrating the retrieval and generation component? When you generate, when you use RAG, then when you do the retrieval and generation both, then what is the primary challenge? Okay, 20D you are saying, 20D, D everybody is saying. Yes, in this case, D is the right answer. And if you see here, and if I make it full screen, right, the primary challenge in RAG is ensuring that the generated text maintains coherence and relevance based on the retrieved document. So basically what you are doing is you are generating something and there is a document which has been retrieved, right? So you need to create that balance between the context of both. That is a critical thing in RAG model. Okay. So what I have done today is I have put 20 questions here, and as you can see, some of all of these are basically deep learning things. Some of these are easy, some of these are difficult, some of these are little confusing knowingly. What I want to do now is I want to show you few things here in the. So this quiz I can do every alternate week or every week, however you want. But what I want to show you, let me stop sharing and share one more time. See, if you go to Unfold Data Science channel here and click on live, then these are the quizzes. For example, last quiz was on RAG and LLM. Before that, recommender system. Before that, ensemble models. So these are theme-based quiz. Today we played for deep learning, and we can keep playing. You can suggest me topics also, and you can suggest me how you want it to be different as well. That's not a problem. Okay. So I'll see you all either next week or next to next week. I mean next Sunday or next to next Sunday. I will announce that in the live. And keep learning. Keep, if you like the quiz, just if you say that yes, I like, thank you, then I will know that you like the quiz. And I'll see you all then next quiz in the live. It's all about learning and it's all about discussing. That is the only purpose. If we give half an hour, 45 minutes of time and our one of the concepts gets brushed up, then there is no problem, right? We can do that. Okay. With that, see you all next time. Till then, wherever you are, keep learning, keep enjoying. Have a lovely rest of the weekend.